Good morning, dear student friends. Today we will discuss about parthenogenesis. Parthenogenesis and another is parthenocarpy. Parthenocarpy. So already you have heard many times these terms in any other classes, but today we will discuss in detail what is parthenogenesis and parthenocarpy. First is parthenogenesis. What is parthenogenesis? It is a type of asexual reproduction. So how, if you compare with sexual reproduction में हम क्या डिस्कस किए? In sexual reproduction, one male gamete, another female gamete is required. When male gamete fuse with female gamete, it produces a zygote, and zygote give rise to an individual or embryo. But in case of parthenogenesis, what happens? One egg is required. There is a requirement of egg. Egg means female gamete. Egg also called as female gamete. Now tell me, what is the ploidy of female gamete? Female gamete is haploid and male gamete is also haploid. And when two haploid get mixed, it produces a diploid zygote. But in case of parthenogenesis, that not happens. In case of parthenogenesis, there is no male gamete. Male gamete is not required. Only female gamete or egg is there. And that haploid egg give rise to a embryo, or embryo, when embryo become big, it produces one individual or offspring. So that's why we can say parthenogenesis is the formation of embryo or individual from an egg or female gamete without fertilization. There is no fertilization. And this is a very important difference between parthenogenesis, parthenocarpy. We will discuss in detail what is the difference between parthenogenesis and parthenocarpy. Sometime it can be asked in the form of short note also. So remember first the definition of parthenogenesis: the formation of individual from an egg without fertilization, means fertilization not takes place here. So as fertilization not takes place, which type of reproduction it is? It is asexual reproduction. It is a type of asexual reproduction because there is no fertilization. But what is parthenocarpy? Parthenocarpy is not formation of individual. यहाँ पर individual formation नहीं होगा. Parthenocarpy is the formation of fruit. Last class we have discussed in previous classes that after sexual reproduction, after fusion of male gamete with female gamete, zygote, embryo, endosperm, these things are formed, and ovary converted into fruit and ovule converted into seeds. That's what we have discussed in normal sexual reproduction. But what is parthenocarpy? Parthenocarpy is the formation of fruit. यहाँ पर fruit formation होगा. Formation of fruit without involving fertilization. No fertilization, but fruit formation takes place. And generally fruit formation takes place from where? Fruit formation takes place from ovary. Already you have discussed ovary converted into fruit and ovule converted into seed. Here ovary converted into fruit, and inside the ovary ovule is present, and inside the ovule what is present? Egg. So that's why we can say direct egg converted into fruit, or female gamete converted into individual in parthenogenesis, the egg or ovary converted into fruit in case of parthenocarpy, and in both cases there is no fertilization. So you have to remember one important thing: what is the similarity between parthenogenesis and parthenocarpy? So partheno, in both sides you can find the term partheno. Partheno means no fertilization. In parthenogenesis there is a formation of individual without fertilization. there is no fertilization. Without fertilization, egg converted into individual. In case of parthenocarpy, there is a formation of fruit from egg without fertilization. Clear? So here fruit is produced, here individuals are produced. But if you compare in normal sexual reproduction, what happens? Only egg is not involved. Egg and a sperm or male gamete. Male gamete, this is male gamete, this is female gamete. So individuals are always diploid in normal double fertilization. But in this case, what you are observing, only N is there. There is no N plus N. So that's why the embryo is haploid or individual are haploid. Individual or embryo is haploid. But if you look in this case, in case of parthenocarpy, fruit is produced. So that's why there is no formation of embryo. So here embryo is produced, here no embryo. So if you write the difference, first is their definition. First, what is the definition of parthenogenesis? Formation of individual from egg without fertilization. And here formation of fruit from ovary, you can say. Egg is not directly involved, from ovary, because ovary is converted to fruit. Ovary without involving fertilization. And second difference, in parthenogenesis, embryo is produced. Embryo is formed. Embryo is produced. Embryo is there in case of parthenogenesis. But in case of parthenocarpy, there is no embryo. Can you find any embryo? There is no embryo because there is fruit. Fruit is produced. There is no embryo. So only fruit. But if you come to parthenogenesis, in case of parthenogenesis, what happens? As there is a formation of individual or embryo, last class I had told you in seed, what is present inside the seed? Seed contain a covering. Inside the seed, what is present? Seed coat inside embryo and endosperm. So that's two type of seed: endospermic seed, non-endospermic seed. That part also we have discussed. So as there is a formation of embryo needs endosperm, and in this case, the endosperm or embryo all are present, but these are haploid. All are haploid because fertilization not takes place, and that's why in this case parthenogenesis you find a viable seed. Viable means living seed. You find viable seed. Viable seed are present in case of parthenogenesis, but in case of parthenocarpy there is no seed production, no seed. So that's why we can say fruit are seedless. The seedless fruits are produced. Seedless fruit. The fruit are seedless, no seed. So seedless fruit. Parthenocarpic fruits are seedless. Parthenocarpic, the fruit which are produced by parthenocarpic fruits, these are seedless in nature, means there is no seed. So that's why we can say, as there is a seed, we can produce a new plant here. It is a type of reproduction, but it is not a type of reproduction only to get fruit. It provides economic benefit to human. So, but it cannot be used for production of a new plant. So new plant cannot be produced in this case. So here viable seeds are produced. Here seedless. Parthenocarpy is seedless in nature. Another important thing, in case of parthenogenesis, the individual which are produced, these are haploid. So that's why it is used in breeding experiment. Used for breeding experiment. Breeding experiment. What is breeding experiment? Breeding experiment is that experiment in which some plants, male and female plants, are reproduced to produce a new variety of plant. So this about breeding experiment I will explain detail in another chapter. Here only you remember, for breeding experiment, used for breeding experiment for production of homozygous plant, for production of homozygous pure plant, homozygous pure. So if you can remember this term homozygous pure, you can remember. Now it is very difficult to explain because this homozygous pure term is in your genetics, another chapter genetics. I will explain at that time what is homozygous pure. So now you remember, otherwise you skip this point. I will explain again in another chapter. So this parthenogenesis is used for production of a breeding experiment used in breeding experiment for production of a homozygous pure product. Similarly, if you look at this side, in case of parthenocarpy, it is not used in breeding experiment. One is used in breeding experiment, another is not used in case of breeding experiment. So you have to remember these things. Another, at the end, you have to remember some example. If you come to examples of parthenogenesis, parthenogenesis is found in turkey, one bird known as turkey, honeybee. In zoology you will read honeybee, about parthenogenesis in honeybee and rotifers. Rotifer is one insect, okay, worm. So this turkey, honeybee and rotifer, this organism you find parthenogenesis. So that's why we can say parthenogenesis takes place in both plants and animals. Another important thing, it takes place in both plant and animal. In case of plant and animal, all organism can show parthenogenesis because there is a formation of individual. In case of plant, parthenogenesis takes place. In case of animal, also parthenogenesis takes place. But if you come to the example of parthenocarpy not takes place in both plant and animal. It only involves plants because fruit formation only takes place in plants. Fruit formation never takes place in animal. So that's why in the parthenocarpy you find in banana. Banana is best example. Many times this question asked in your NEET. Banana, another is grapes and citrus. These are common example of parthenocarpy. And parthenocarpy only takes place in plants, not in animal. So these are the basic differences between parthenogenesis and parthenocarpy. You have to remember it. What is parthenogenesis and a parthenocarpy? So these are the important points. At least you have to write 4 to 5 points in each side for parthenogenesis and a parthenocarpy. Clear? Now we will move towards another part. Parthenogenesis, parthenocarpy completed. So parthenogenesis is very important for both plants and animals for asexual reproduction because there is formation of individual without involving double fertilization. Now we will move towards another part. Today we will discuss some questions because we have reached towards the last end of this chapter. In one class we will complete the entire chapter, and now we will discuss some questions important for NEET as well as your board exam. So, question number 1. In which type of pollination attractant and rewards are given by plant? Attractants and rewards given by plant. Options. Number 1 is wind pollination. Second is water pollination. C is insect pollination. D is bat pollination. Second question. Which type of pollination is rarest, is least or rarest, least used by plants? Least used by plants means minimum used by plants. Number 1 wind pollination, same options. Water pollination. C insect pollination. D bat pollination. First we will solve these 2 questions, then we will move towards other questions. So first listen the number 1 question. In which type of pollination? Attractants. Attractants means plant has to attract. Attract already we have studied. For plants to attract, there is a different color in plants. The flower color. So color attracts. Number one is color. Color attract what? Color attract insects. Color. Another is fragrance. Fragrance. Fragrance means sweet smell. Fragrance also attracts. One is color. Color attracts by color. Red color, yellow color attracts. Fragrance also attracts. And another important thing is reward. This another is in case of flies. Flies is foul odor. Foul odor. Foul odor. Foul odor means bad smells. Clear? And if you come to the reward, what are the reward given by the plant? The rewards are mainly nectar, edible pollen. These are the rewards given by the plants. And these rewards and attractants given in which type of pollination? The answer is insect. Insect. Because wind and water are non-living. Wind and water are non-living, abiotic. And these two are biotic. Now question comes. Out of insect and bat, which one? Both are living. This is insect is living, bat is living. But more attractant and rewards are given in insect pollination. Less is given in bat. So best answer is your insect. Bat is also living, but attractant and rewards not given more to the bat. It is only in few plants. But 80% pollination, 70 to 80%, I have told you, the insect pollination takes place. And which one is the dominant insect helps in pollination? The dominant insect is bee. Honeybee. Bee is the dominant biotic pollinating agent in case of plants. So that's why attractants and rewards are given in insect pollination. And if you recall, wind pollination is called anemophily, water pollination is called hydrophily, insect pollination is called entomophily, bat pollination is called cheropterophily, and mollusca pollination is called as malacophily. Okay, so this completes your first question. Now come to second question. Second question is written, which type of pollination is least used? Least means minimum. Least means minimum. Minimum used by plants. Already I had explained. Out of biotic and abiotic, if you compare abiotic, two type of agent are there, abiotic and biotic pollinating agent. Most of the plant prefer biotic agent. Abiotic agents are not generally used, and under abiotic agent are very less. And abiotic agent, why they are less or least used? Because they are non-living, so that's why chance of pollination is very less. Because maximum waste of pollen grain takes place. Why waste of pollen grain takes place? I had already explained it. The wastage of pollen grain takes place due to high speed of wind or non-directional, because wind can move in any direction, water can move in any direction. So that's why abiotic, under abiotic there is air, wind, another is water. So out of air and water, again air is more used, so water is the least. So water pollination or hydrophily is the least used by plants, minimum. And you can remember it is restricted to only 30 genera. 30 genera, in ancient book it is written, it is restricted to 30 genera. Genera means genus of plants. Just like the species, above the species there is another term known as genus. So it is restricted to 30 genera of plants. Clear? So it is the rarest type of pollination. Now we'll move towards another important question. So this one completed. Another important question which is for entrance, question number 3. Calculate the minimum number of meiosis required to produce to produce 200 zygote or embryo. It can be asked in any form. In some question direct embryo is written, in some question zygote will be written. So you have to remember same. What is zygote? Same, because zygote when divide it produces embryo. So calculate the minimum number of meiosis required to produce a zygote or embryo. Zygote or embryo. Meiosis पूछा है. What is the question? Meiosis. Question is very easy. You can calculate it. Calculate the minimum number of meiosis required to produce 200 zygote or 200 embryo. 200 zygotes. Okay. So for entrance point of view, there is one shortcut. I am telling in short what is the answer. Then I will detail explain. So answer, if this type of question you will get 200 zygote, 200 embryo, or sometimes 200 seed also asked, because embryo is present inside the seed. Yes or no? Embryo is present inside the seed, and it is a general condition. Not we are not taking polyembryony. You cannot confuse here with respect to polyembryony. So polyembryony is not used. It is a normal condition. How many zygote, embryo, or seed? The answer shortcut for this, if you get this type of question, to know the number of seed, to know the number of seed or number of embryo or number of zygote, there is a direct formula: n into n plus 1. N plus n by 4. This is the formula. N plus n by 4. What is n? N is the number given. N is the number of zygote. Number of zygote given or number of seed given. So here what will be the answer? Answer will be 200 plus 200 divided by 4. So answer is 250. So this is the answer. Clear? How many meiosis required to produce 200 zygote? N plus n by 4. Why the n plus n by 4 is taken? I am giving the detailed explanation. Now come to explanation. So first tell me, when meiosis takes place in sexual reproduction. In sexual reproduction, at two places we have discussed meiosis takes place. One is microsporogenesis, another is megasporogenesis. Microsporogenesis. Recall microsporogenesis. Microsporogenesis, another is megasporogenesis. Megasporogenesis. Microsporogenesis and megasporogenesis. Microsporogenesis is related with male. Megasporogenesis is related with female. So what happened in microsporogenesis? There is one microspore mother cell, MMC, and a microspore mother cell undergo meiosis. Meiosis to produce how many microspore? 4 microspores. And these microspores converted into pollen grain. First microspores are produced. Microspores converted into pollen grain. So 4 microspores means 4 pollen grain, and a pollen grain contain one vegetative and a genitive cell. Genitive cell divides to produce male gamete. So that's why we can say, so each microspore produce male gamete, and out of 2 male gamete, 1 male gamete contribute. The pollen grain contain vegetative and genitive cell. 1 male gamete contribute to zygote, and another male gamete fuses for triple fusion. So that's why we can say 1 pollen grain produce 1 zygote. So 4 pollen grain will produce 4 zygote. 4 pollen grain will produce 4 zygote. We are discussing about zygote, clear? Not about endosperm. So 4 microspore will produce 4 zygote. So that's why, tell me, how many meiosis will be required to produce 200 zygote? 200 zygote. For 200 zygote, first there is requirement of 200 male gamete. So as there is 200 male gamete, what is the number of meiosis? In this case, number of meiosis required. So as 4 produce 4 zygote, the number of meiosis required to produce 200 zygote in this case will be 200. So that's why 200 in this case. So 4, there is 1 meiosis produces 4. So to produce 200, 50 तो 50 into 4 give rise to 200. Yes or no? So 50 into 4 200. So that's why you can say 50 pollen grain. As one meiosis produces 4, because question is asked how many meiosis required. So 4 pollen grain are produced from one microspore mother cell by one meiosis. The question is asked how many meiosis. So one meiosis produces 4 pollen grain. One meiosis produces 4 pollen grain. So we can say 50 meiosis. If there is 50 meiosis, there is 50 meiosis. How many pollen grain? 4 pollen grain in each. So 50 meiosis into 4 pollen grain in each equal to 200 pollen grain. If there is 200 pollen grain, it can fuse with 200 egg to produce 200 zygote. So now male side complete. Male side there will be requirement of 200. 200 from how many meiosis? 50 meiosis. If you consider the same 200 for 200 zygote in female side, what is the requirement in female side? Female side is a megasporogenesis. Megasporogenesis means the megaspore mother cell undergo meiosis to produce again 4 megaspore. But here I had explained you, when meiosis takes place, after meiosis 3 megaspore degenerate, only one is functional. So that's why one meiosis produces 1 megaspore, but here one meiosis produces 4 microspore. So difference, here 4 microspores are produced, but here 1 microspore is produced. So that's why for 200 zygote, what is the requirement? Here the requirement as 1 microspore, sorry, here megaspore, 1 megaspore, here megaspore, 1 megaspore is viable. So in this case, to produce 200 meiosis is required. Here 4 microspores are viable, living. So that's why 50 is sufficient, because 50 into 4 is 200. But here only 1 is living. 4 are produced, but 1 is living. So that's why here we cannot use 50. Here 200 into 1, because we have to reach at 200 zygote. So 200 zygote is produced. For production of 200 zygote, how many meiosis in female side? 200 meiosis in female side. 200 meiosis, because there is only one viable. Clear? So 200 into 1 is 200. 50 into 4 is 200. So now combine these two, 200 plus 50. How much it become? 250. So that's why you only remember the meiosis, the amount of meiosis required for production of zygote or seed. In this case, in case of male, all are viable. So that's why you have to multiply with 4 for production of 200, or direct word you can divide. To get 50, you have to divide the 4 with 200. 200 divided by 4 is 50, and direct, there is no division, because this side 200 by 1 means n. So that's why this is n, this side is n by 4. So that's why formula is n plus n by 4. Clear? So this is the formula. Directly you can calculate the minimum number of meiosis required for production of the definite number of zygote or embryo or seed. Whatever the question may be, you can directly calculate the answer. Okay, so this much for today. We'll continue from this in the next lecture. Thank you.